So I want to now formally introduce when I said covering all the vectors in R2 or covering all the vectors in some Rn space. So that is called the span of the set of vectors. Okay. So the set of all possible vectors which can be obtained from the linear combinations of a set of vectors is called the span of S. Fine. So I also mentioned span briefly before, like it was a slip of tongue, but I wanted to formally define it here. So all the linear combinations of any two vectors or any set of vectors is basically called the span of S, right? So if I have to get the span of 1, 0 and 0, 1, can anybody tell me what's the span of these two vectors?
R2.
This is R2, right? Clear to everyone, right? Everybody, can you please respond on chat? So Rayudu is saying XY plane, correct? Basically R2. Nobode is also saying that understood, right? So the span of, so I will say span of these two vectors, 1, 0 and 0, 1. This is a set and span is basically R2 or the XY plane. Formally, we call the XY plane as R2 in linear algebra. Fine. Let's do the span of these vectors. Can you all actually tell me what is the span of these two vectors? We saw it previously.
R2.
And R2 only, right? We saw it that it's R2, right? Because we were able to obtain 1 and 1, 0, 0, 1 vector, the special vectors of R2, and from the linear combination of these two vectors, thus we will be able to span a whole R2 using these two vectors, right? And what will be the span of these two vectors?
They didn't span R2.
It will not span R2. Fine. But what will be the span of R2? Sorry, what will be the span of these two vectors?
R1. R1.
Will it be R1?
No, sorry.
So R1 is basically this. Okay. R1 is 0, 1, -1, right? So, yeah. So this is not, so this is R1. So will it span R1? No, right?
Sorry. You
Yeah,
span a set which is T into or a constant into 2 pi.
correct. So basically it will be, Nobodha has also said it, that line passing these 2 points. So Nobodha, first of all, I get it what you meant, but these are two vectors, okay? These are not points. But obviously, if you connect origin and point, you will get this vector. But in terms of these vectors, if I have to write, right, I will write the span of two vectors, or I will write the span of this will be something as A 2, 5, where A belongs to the real numbers. Fine. So basically the line or the vectors on which all these two, or the line in which these two two vectors were lying, or even the points are lying, right? So we saw it here that our vectors lied on this particular line. So this is the span of those two vectors. Fine. So this is one vector, two vector, and this is the linear combination of this is all the linear combination of those two vectors, and it's a line. Fine. So right. So this is the span of these two vectors. Fine. Everybody clear till now, right? You can comment also in the chat box. Clear, right? Awesome. Fine. Okay. Now tell me what will be the span of this vector.
The origin.
Origin or this. So again, you guys are talking in terms of points, right? I want to talk about these things in terms of vectors, not points. Okay. So origin is a point.
Null vector or something.
Origin is a point, right? So we have to talk about vectors because it's defined for vectors. It's not defined for points, right? It's set of all possible vectors which can be obtained from the linear combinations of the set of the vectors that we are talking about, right? So we should be talking about vectors, right? But you were right that I get it that you understood that the span of this particular vector will be the origin vector or the zero vector itself. We don't call it the origin vector. Origin is the point, and zero vector is the term that we use. Okay, zero vector. Usually we have this, but we'll just denote it with like a little thicker zero, right? Null vector or yeah. So zero vector is the span of this particular set. Okay. Now let's come to the span of these two vectors, right? So it's a little difficult to come to it, but let's visualize it, right? So I'll switch to the 3D version of this. So these are my two vectors, right? These are my two vectors. You can see that they are here. Can anyone tell me what will be the span of these two vectors? So if it's not clear, let's see a demonstration. Fine. So I will demonstrate this to you. I will actually play this. Okay. Can you see what is this?
Yeah, plane.
It's a plane, right? It's not a 3D, right? You can see. And what plane is this? If I have to specify some properties of this plane, what plane will it be? So this is a plane where
Passes through the origin.
it passes through the origin and these two vectors lie, right? So you can see that these two vectors completely lie in this plane, right? Right. So this is the plane. Fine. So coming back to my question, span of these two vectors. Now anybody can say it loud. What is the span of these two vectors? Span of. Everybody understood it, right? See the chat box. Plane where the two vector lies. Awesome. So Nobodaya has said this. Varshita, Rohan, can you also reply on the chat box if you have understood?
Yeah.
Correct, right? Varshita, clear, right?
Yes, ma'am.
Awesome. So it'll be a plane where these two vectors lie. Fine. Let's move on. So let's answer this question. What will be the span of these three vectors, right? So it's not very evident. Let's go back to our visualization again. I will turn this off and I will try to turn this off as well. Okay. So these are my three vectors. These are the three vectors I talked about. Okay. So you can visualize these three vectors, right? Do they seem to be on the same plane? No, right? So let's see. I will take the linear combination of these. Visualize this. Yeah. Can you see what is this? Like what can anybody, it's not completely getting filled, but it's not a plane, right? Can you see a 3D image coming up? Like a 3D
Yes.
3D kind of a thing coming up. So it's not a plane. We can see clearly this is not a plane, right? And if I run it long enough, what will it become?
Three D space will get
Sorry?
the whole 3D space will get filled.
Right. So what is the linear algebra term for the 3D space?
R3, ma'am.
R3, right? Awesome. So this is clear to everyone, right? That this will actually all the three vectors, the linear combination of these three vectors will fill up the whole R3. Fine. So this is so span of, let me see if I can. Span of, I will call them A, B, C. Span of A, B, C is equals to R3. So this is very important to understand, right? So if not clear to anyone, please get it clarified right now only. Varshita, Raidu, Nobode, Rohan, everybody clear on this, right? That this is going to span the whole R3 vector space or space, R3
Yes, ma'am.
space.
Ma'am, as we have the GeoGebra platform, we are executing them and saying whether it is spanning R3 or not. By manually, how can we say that it gets span R3?
Yeah. So that's a very good question. We'll come to that later in the course. So right now, I'm only showing it to you geometrically. Somebody, I think, yes. Varshita, a lot of noise is coming from your end. Yeah. So right now, your question is very valid that because I'm showing it to you on GeoGebra platform, you are able to see that, okay, this is spanning a R3 space, but how do you know that? We'll come to that later in the course. Fine. Actually, we'll come to this now only. I'll briefly touch upon it in this and formally we'll explore this idea when we talk about a rank and when we are doing the solving system of linear equations. Fine, but I'll briefly touch upon it here. Fine. Now let's move on to this other set. So can anybody tell me what will be the span of these three vectors? And first look at these vectors properly and then answer. And we don't need GeoGebra to visualize this. We can visualize it, but it's not required.
Same
That
as the
addition of first and second.
Sorry. You can write it on the chat box as well. No issue. A plus B is equals to C. Correct. So Raidu is right that A plus B is equals to C, which is these are the three vectors A, B, and C, right? So A plus B is equals to C. So basically, C is a linear combination of A and B. Of A and B. Okay. So now what will be the span of these three vectors? You can comment in the chat box. Okay. So Nabodha is saying that it will be the plane on which they lie, right? They means A and B, right? So basically, the span of A, B, and C will be equal to span of A and B only, because C is a linear combination of A and B, which means a plane passing through A, B, or a plane where A and B lie. Clear? Correct. So let me see if I have it on GeoGebra. I actually have it. Okay, I will remove this vector and I will see this vector. Okay. So first of all, see that these three vectors, right? They sort of are on the same plane, right? Everybody can see that their plane is same. If not, let me take the linear combination of this as well. Linear combination of this. I've not added that. So let me add that. Plus CE. Okay. And I will do settings. I will show the trace of this. And I will play this for you. Okay. Can you see this is a plane, right? So indeed, these three vectors are actually all lying on this plane because the C vector was a linear combination of A and B itself. So the span of these three vectors will be the linear combination of vector A and B, which is a plane from which A and B pass, or on the plane which A and B lie, right? Clear to everyone?
Yes, ma'am.
Cool. Just this. Fine. Now let's come back to this. Okay. So we have taken the span of these three vectors. So now tell me what will be the span of these three vectors, which are where each vector is an R2. You can comment in the chat box or you can unmute yourself and reply. Anything is fine. So what will be the span of these three vectors?
R2.
Why is that?
Because the first two spanned R2 earlier, and then the third one is nothing but the linear combination of the first two. Again, it will not implement anything.
Correct. So span of A, B, and C is R2 only because these two span the whole R2. We have already seen this, right? So whatever is coming from R2, apart from these two, will also lie on in the R2 only, right? And will be a linear combination of these two, right? So the span of A, B, and C again is R2, right? So we saw that 4, 7 is somewhat redundant, right? Redundant in the sense, like someone already said, that it's not adding any new information, not adding anything to the span, not adding anything to the span of A and B, right? Because, so this is somewhat a redundant vector because 4, 7 is a linear combination of vector A and B. And I will say this is A and B. So this vector is not adding new information or any new direction to the span of A and B so that it's able to span a higher dimension space. Fine. So these kind of vectors are actually called, so when we said take this set, right? This whole set of these three vectors. This set is actually called a linearly dependent set of vectors. Fine. So because 4, 7 is a linear combination of 1 and 2 and 2 and 3. This is a vector. The way we say it is it's dependent vector, right? And the term linearly dependent is actually defined for a set of vectors and it's not defined for a vector. So we say that the set as a whole is a linearly dependent set of vectors. Clear? It's clear to everyone, right? Please comment on the chat box or unmute yourself and let me know. Okay, fine. Clear to everyone. Varshita, clear, right? Yeah, you already replied. Fine. Right? So if you have three vectors in R2, will it always be a linearly dependent set? Okay. Before that, let's see what is an linearly independent set. So these two vectors, which were spanning R2, were not a linear combination of each other, right? So this whole set was a linearly independent set. Fine. Let's come to that question later, which I was asking. Let me formally define the linear independence for you guys. Fine.